Good morning, dear students. Previously, we discussed classification of monosaccharide. That is most important question related to the exam point of view. I hope that is clear to you all and you have practiced that structures. Today, we will discuss the properties of monosaccharide. It is on page number 104, and first of all, we will discuss the tidbit. It is important in MCQs. So focus on that. General properties are that in the tidbit the plain polarized light is discussed and the behavior of the monosaccharide molecules toward this plain polarized light. First of all, plain polarized light. The light beam, the rays which are traveling in a single direction are called the plain polarized light. Monosaccharide molecules have the ability to rotate that plain polarized light into the right. That type of monosaccharides are called the dextrorotatory, or simply they are called the dextrose sugars. While the molecules which can rotate the plain polarized light towards the left means the anticlockwise direction, so they are called the levorotatory molecules of monosaccharide. Monosaccharides are called reducing sugar because they are reducing in nature. They have the reducing powers, reducing agent properties they contain. So glucose which can dissolve in small amounts of water to make a syrup. It means that 1 centimeter cube, which is a very much little quantity of water, 1 gram can be dissolved and it can make a syrup of glucose. That is important in the dextrose drips. We have already discussed that point. The physical properties of monosaccharides are that monosaccharides have sweet taste. Fructose is the sweetest. Fructose is the monosaccharide which is the sweetest of all. It is about 73% more sweeter than sucrose. Sucrose is the common sugar which we use in our daily life, and fructose is 73% more sweeter than that. Means to say that the honey, you definitely have tasted that honey contains a much higher quantity of fructose. Same is the case with the commercial candies, the central filled candies, the jelly like structure or the jam like structure present in the jam like material which is present in between within the central filled candy. You may have tasted that it is much more sweeter, so it contains higher quantity of fructose. Fructose is very much important in the energy. As you can see in the tidbit of your book, page 106, that studies have shown that honey has the same quick absorption and long-lasting energy burst effect that many sports drinks do. Fine, it is a natural way to boost the energy. What? The honey. This is because honey is high in fructose and a simple fruit sugar that has been found to be the best sugar for athletes. Unpasteurized means the natural, unprocessed. Honey also contains hydrogen peroxide and enzymes which aid in digestion. It is important in the long-lasting energy because of its quick absorption and energy production. Clear? And it is having the same effect as the sports drinks too, and it is important for the athletes and it is also important in the digestion. Fine. So come towards the physical properties again. So they are usually colorless crystalline solids at room temperature. They are completely soluble in water. Why they are soluble in water? Because they contain the polyhydroxy. These are the polyhydroxyaldehyde or ketone, where whenever there is polyhydroxy means the hydroxyl groups are there, so they can easily make the hydrogen bond with the water, and those compounds can easily get dissolved in water due to the hydrogen bonding. The second class of carbohydrates are the oligosaccharides. It is the second class of carbohydrate. Fine. Carbohydrates which on hydrolysis means reaction with water, give 2 to 9 molecules of monosaccharides or simple sugar are called oligosaccharide. It means that oligosaccharides are formed by the combination of 2 to 9 monosaccharide units. Or we can say that when these oligosaccharides are broken by the hydrolysis, they can produce 2 to 9 monosaccharide units. Getting it? The oligosaccharides are further classified on the basis of number of monosaccharide molecules they produce. They can be disaccharide, trisaccharide, tetrasaccharide. Disaccharides are those oligosaccharides which on hydrolysis produce 2 molecules of monosaccharide. Tri will be those which will produce 3 molecules on hydrolysis, and 4 tetrasaccharides are those oligosaccharides which can produce 4 monosaccharide units on hydrolysis. These are the disaccharides. First of all, you can see sucrose is there. When it is hydrolyzed, the water written on the arrow shows that water is the medium, means to say that the sucrose is hydrolyzed and it will produce two monosaccharide units, the glucose and fructose. Clear? And lactose, when it is hydrolyzed, it gives us the glucose and galactose. Maltose is hydrolyzed to give glucose plus glucose. Clear? Means to say that the glucose and fructose combine together sucrose, or we can say the sucrose on hydrolysis produced glucose and fructose. What is sucrose? It is the disaccharide. What is disaccharide? It is the type of oligosaccharide. Properties of oligosaccharides are that these are the white crystalline solids. Recall your memory, when the monosaccharides were also crystalline solids. They were colorless crystalline solid, but oligosaccharides are white crystalline solids. They are soluble in water. Monosaccharides were also soluble in water. They are sweet in taste. They were also sweet in taste. Do remember these questions, these type of properties in comparison form, so you can learn them easily. The next we are having is the glycosidic linkage. Glycosidic linkage or bond is the link between the rings in an oligosaccharide or polysaccharide. Oligosaccharide, which are made up of monosaccharides, polysaccharides, which are again made up of monosaccharides or oligosaccharide. So how they can join together? They can join together by means of the glycosidic linkage. Glycosidic linkage is a bond which is formed due to the condensation, removal of water from the monosaccharide units, and they can get combined together. Look at the structure, the reaction. In the first part of the reaction, we are having two monosaccharide units. On the left hand side of the reactants, we are having the glucose and plus fructose is there. So you can see that water molecule is eliminated by the two from the two monosaccharide units, and they have joined together with the help of an oxygen atom. The linkage is formed, and this linkage is called the glycosidic linkage, and we will get a disaccharide. If three molecules combine together, so two molecules of water will be eliminated and we will get a trisaccharide, and so on. Polysaccharide is the next type of the carbohydrates. Polysaccharides, poly means many saccharon units will be there, so they are the biopolymers of monosaccharide. Biopolymer means the polymers, the higher molecules, the larger molecules which are required for the living organism. They are called the biopolymers of monosaccharide, or we can say that monosaccharides are the biomonomers of polysaccharide. Carbohydrates, which consist of long chain of monosaccharides units bound together by glycosidic linkage, are called polysaccharides. They are also known as macromolecules. Their examples are starch, glycogen, cellulose, etc. Their properties is that they are amorphous solids. Amorphous solids means they are not crystalline. They do not have any particular shape or structure. They are tasteless. The other two were sweet in taste. They are insoluble. The other two were soluble. They are called non-sugars. The others were called the sugars. They have high molecular masses, consist of 100 or more monosaccharide units. Hydrolysis of polysaccharide gave many molecules of monosaccharides. You can see in the reaction that starch is there, it is hydrolyzed, and in the presence of H positive. H positive indicates that there is an acid, so it will be converted again into glucose. This is the summary of classification of carbohydrates. First of all, broadly it is classified into monosaccharide, oligosaccharide and polysaccharide. Monosaccharides are divided into further types. If you remember that we discussed that monosaccharides are divided on two bases. One is on the basis of carbon number, triosis, tetrosis, pentosis, hexosis and haptosis, etc. While the other one classification was on the basis of functional group. The aldehydic functional group containing carbohydrates were called monosaccharides were called the aldoses, while the other one having ketonic functional group were called the ketosis. Clear? Oligosaccharides are disaccharides, trisaccharide, tetrasaccharide, etc. While polysaccharides are structural polysaccharides which can make the structure. For example, the cellulose, or it can act as a storage house for the storage of glucose. In plants, it will store the glucose into starch, and in animal sources the stored glucose is called the glycogen, and which is a polysaccharide.